Hello everyone. Today we are about to talk tactical detection. This topic might be new to you, but if you are in a cybersecurity domain, you should know what is tactical detection and what is tactical engineering. This is a recent TryHackMe room where they explained this detection engineering and purple teaming in a beginner level. So at the end of this room, you'll be having an idea what is detection engineering, what the purple team does. And here, let me admit, this room has more theoretical part than the practical stuff. So bear with me. I'll try to explain this as simple as possible. Before I explain what is detection engineering and the purple team, let me explain briefly about the incident responders role. If there is an incident responder in an organization, they will be getting the alerts from various devices like IPS, IDS, SIEM, those security tools. And those alerts are about a threat, security incident, cyber attack, and some intrusion attempts. They'll be getting this kind of security alerts. And their job is to analyze that alert, examine the specific log stuff, and address that issue, mitigate that incident. That is their role, the role of incident responder. But the role of detection engineer and the purple teaming is as important as the role of incident responder. I'll tell you how. In incident response, as I said, their role is to respond to an incident. Once the incident happened, they are responding to that incident. But the role of detection engineer is more important than the incident responder. I'll say how. The role of detection engineering is to write a signature, to write a rule that detects the specific suspicious event, specific behavior in an endpoint. That is quite important. And this room talks about that kind of detection rule writing. And the purple teaming, actually, you have heard both red team and blue team, but purple teaming is the combination of both red and blue. They do the offensive side work and also the defensive side work. I'll tell you in an example. If there is a 0-day cyber attack, a role of detection engineer is to examine, to analyze that specific 0-day threat and write a detection logic for that and deploy the detection logic in their SIEM or any other solution. And they have to test that rule, the efficacy of that rule, by triggering that rule with the same kind of attack. They have to conduct that, they have to recreate that real-time attack in order to test the rule capability, whether the rule properly detects that or not. So here, that specific team does both red team and blue team stuff. They are doing the defensive part, creating the rule. Also, they are testing that specific rule's efficacy by manually creating that specific cyber attack. So in that place, they are doing both red team and blue team work. That's why the team is called purple team. And this room is completely about that. And this room, in fact, this room contains how can you collect the IOCs, the indicators of compromise, how you can aggregate those IOCs into a rule signature, how can you write a signature rule, what are the open source rules are available, and how can you adapt that rules in an SIEM solution that you are having. So those things we are going to discuss in this room. And look at this tagline: establish a baseline knowledge of tactical detection, leveraging efficient techniques to bolster your security posture. All right. Now let's read through this theoretical part. It might be boring, but stick with me. It will be very interesting at the end. And introduction. You are hired as a security engineer and you want to make a good impression. You noticed that there is a default rule set available and it has already been enabled. The SOC team seems to function, albeit not as efficiently as you might expect. Then it dawns on you, the default rules just won't cut it. This scenario is not uncommon. In fact, a common pitfall of modern SOC today is leaning too much on default rules and setting the products they deploy leaving them as the security alerts that they don't really add values to their security posture. All right, what they are trying to say here. For example, if you are getting an IPS solution from a vendor, they should be having the default set of signatures and the default set of rules. If you get that solution and if you deploy it in your environment, leave as it is. Buy, deploy, and leave as it is. Then any logs passes through that IPS IDS solution, then it will only correlate with that specific already available signature. It won't look for the new threats, the 0-day threats. In that place only, the role of detection engineering comes in, where they are writing new rules manually with new logics, with new threats. For emerging threats, the detection engineers are creating logic and they are deploying that specific new detection logic to that security solution. So what will happen? Automatically, whenever that emerging new threat comes into our infra, it will be detected by security solutions that we deployed. So that is what they are explaining here in this paragraph. And the learning objectives you can see here. In this room, we will try to understand the mindset behind choosing a tactical approach in alerting and detecting threats, IOA, IOCs, etc. In the process, we will gain practical experience in setting up a basic detection capability, leveraging techniques used in real life environments, and room prerequisites and exception settings. So they gave expectation setting. They gave a prerequisite, but I don't think there is any significant prerequisites. There are no hard prerequisites in order to gain value from this room. However, it would be very helpful to have basic understanding of navigating command and executing basic commands, as well as navigating full event log view, as it would be our main tool in reviewing the event logs. All right. Now, in this room, we are going to use a Windows machine to experiment some of the tactical detection stuff. And for that, they actually have a tool called full event log view. So this is the tool to view the Windows event logs. And you must be familiar with the command line, Windows command line. And this room will touch upon some of the most efficient ways to bolster an organization's security posture by leveraging detection mechanisms and walking user through setting them up tactically. They should serve as a baseline where the user will be able to learn the basics, implement them in their functions, and make them truly on their own. All right. Now, the first part is done. The introduction is done. Let's move to the next one. Unique threat intel. Looks like it talks about collecting the indicators of compromise from various threat intelligence resources. Now let's read through this. You stumbled upon documentation of a previous incident containing a couple of unique indicators of compromise. Unique IOCs of previous intrusions are good example of threat intel, as they are the traces of specific adversary that your environment has already faced. The inclusion of these IOCs in your detection mechanisms will help to spot the reintrusion of that specific adversary immediately among the others. Now, what they are trying to say, whenever you are collecting certain IOCs from the previous intrusion, you can use those IOCs to build the detection rule. So what will happen? Automatically, next time when the same threat actor adversary try to compromise your systems, you will be alerted. So that's what they are trying to say. You may use the IOCs that are publicly available to bolster your security. And look at these two images. It has one executable file and its path, its file size, and its description. It says it is downloaded from the internet. And you can see some domain names and its description. And the domain names, you can see the description. From the description, you can understand the domain of the source of the malicious executable file. So this executable file downloaded from this specific domain mentioned in the first. And the second and third domains are related to this first domain, and these two domains also known to be malicious, and that's why they have mentioned here. Now from these two images you can understand the file name and the list of domain names. So these things fall under the indicators of compromise category. And let's read through the next para. The screenshots above are excerpts from the spreadsheet that contains IOCs that can be integrated with the organization's current detection mechanism. It is more or less the same format that incident responders use as they go through their investigation. Logging in IOCs in a file like this allows for better collaboration among multiple incident responders. It also makes scoping of the incident more effective. More often than not, IOCs lead to more IOCs. And once you get any domain name or any other sort of IP address sort of IOCs, then you must do some investigation, some enumeration, and you have to find the IOCs related to that. So that you'll be able to add those IOCs as well in your detection logic. It will be giving you some added advantage. And the next para, in the spreadsheet excerpt above, based on the description, the direct indicator found by the authors of the documentation is actually just the domain name. And however, upon further inspection of the malicious domain, they were able to conclude that two other malicious domains should be recorded IOCs due to their association with the original malicious domain. So what they did here, they got to know this specific first domain initially. Then later, the second and third domain they found to be associated with the first one. And they found that at the end of the enumeration they did. And to maximize our efficiency, we will transform these IOCs into detection rules in a vendor agnostic format using Sigma. And look at this word Sigma. Sigma, actually it's a signature format. It's an open source signature format. By using this, you can write a signature and you will be able to convert that signature into any other SIEM format. I'll explain in the next section, but just understand what is Sigma right now. Sigma is an open source generic signature language developed to describe the log events in a structured format. And this allows quick sharing of detection methods by security analysts. And you can see the basic example that they have given here. Bad domains.yml. We have seen few bad domains here, and this rule actually to detect these bad domains. Whenever there is a connection made to these domains, this rule will be detecting those kind of attempts. And look at this rule here. It contains a title, status, description, author, date, modified date, and here the log source. The log source category is proxy. So here we can define from which device we are collecting the logs. And here it is actually inspects the proxy logs. That's why they have mentioned the log source category as proxy. And here is the detection part. And here in the detection, under the selection option, they mentioned the CURI extension, and it is EXE. So the specific title denotes the file extension, and we are looking for the executable file, and that's what we have mentioned here in this specific part. And at the bottom you can see, below you can see r-DNS topic. Under this DNS topic, we can see all the three malicious domains, and the condition is selection. We are choosing this selection part here in the condition. So what will happen whenever the executable file is downloaded from any of these domains, it will be triggering the alert. And you can see the false positive they have mentioned as unknown. If there is any false positive, then you can feel free to mention it here. And they have mentioned the rule severity. All right. The Sigma rule that we came up with from the IOCs presented above is very simple and straightforward. Yet additional layer of detection that gives the organizations is invaluable. In a grander scheme of things, these layers work together to give your analysts the visibility that they need to spot bad actors before it's too late. Remember that the bad guys need to circumvent all our defenses in order to get their objectives, but we only need them to fail one layer of detection to have an idea that they are there. So I think you can understand this specific line, what they are trying to say. As a threat actor, you have to exploit all the layers of defenses to get the fruitful stuff. But as a defender, you have to detect that bad actor at any layer, right? So that is what they are trying to explain. And compared to the threat actor, our job is a bit easy in that. Well, okay, now let's try to answer these questions. what did we use to transform the IOCs as detection rules in a vendor agnostic format? And the rule is sigma. We are using sigma rule to convert it into the signature. And what is the original indicator found by the authors of documentation? What is written in the spreadsheet? Well, we can see the original URL, the original domain here, and here is the exact domain. So this is what they are asking. So this would be the answer now. And I'm removing the defanged stuff, and that's the answer. And the next one, what is the full file path of the malicious file downloaded from the internet? And they're asking the full file path of the malicious stuff. So here is the malicious executable, and the full file path is the C drive downloads directory, and the file name is bad3xe69, bad3xe69.exe, and the path is downloads, and that's the right answer. In the sigma rule bad-domains.yaml, what is the log source category used by the author? And the log source, as I mentioned before, it's a proxy logs. The rule is written for the proxy logs, and that's the answer. All right, so it's a complete theory. Moving to the next one. The next section is also a theoretical stuff, but the fourth task would be some practical one. But before getting into that, let's complete this theoretical stuff. And yeah, publicly generated IOCs. You are feeling proud of yourself for being able to implement detection rules that they have an immediate impact on the organization when suddenly news break out of a new zero-day vulnerability. Upon taking a closer look at it, you realize that your organization is directly susceptible to this vulnerability. Okay, here is the scenario. And you don't have to be able to experience everything in order to learn from something. You can learn from other people's experience or research or learnings. Analogous to that is that the array of research being done by the community, and almost always they release public IOCs. These public IOCs are then transformed into usable mechanisms to detect bad things in the environment. Now, here in this paragraph, they are suggesting us to get the IOCs from various resources from the community, and you may use those IOCs to build your detection logic, your detection rule signature, and that's what they are suggesting here. And the next para, going back to our previous task, we have leveraged sigma to transform unique IOCs into product agnostic form that we can use regardless of your SIEM choice. As this technique shows great promise to the community, there are a number of nice repositories that contains user submitted sigma rules that anyone can use. You can plug one directly into your SIEM for immediate value, or further edit it to fit your environment and add even more value to your security posture. Yeah, that's what they are saying. There are a lot of variable resources available out there from where you'll be able to gather the SIEM rules, the sigma rules, and you can convert the sigma rule to various SIEMs. And that's what they are suggesting. Well, okay. The following is a nice exercise. Write a detection rule of these two. Transform these publicly generated IOCs into usable alerts for the use in the Elastic Stack and Splunk. And we will do the first one together. We will get well, you can do the rest on your own. For our purposes, we'll be using the unique uncoder to help with the transformation of these sigma rules. Uncoder is a nice tool that helps convert sigma rules to queries that can immediately used within the SIEM of your choice. All right, you can see the following sigma rule blocks. Actually, these sigma rule blocks build by using the various IOCs collected. And let's look at these sigma rules first. So the first one, a fairly recent zero-day vulnerability, Folina MSDT. The Folina MSDT vulnerability was present. It's a remote code execution vulnerability found in the Microsoft Office. And by leveraging this, anyone can execute the code on the target system. Well, a sigma rule developed in order to, the sigma rule was developed to find this Folina vulnerability. And here is the rule. The first thing, the description, title, ID, status, those things, and the reference, reference URL, author, tags, that is fine. The tag says attack.execution. All right. And look at the log source. The category is process creation and the product is Windows. So this specific rule is for Windows logs. Well, the next section is the detection section. And in the detection section, you can see the various selection section under the detection. Selection 1, selection 2, selection 3. And every section contains a specific condition, an image that ends with msdt.exe, okay. And the second one, the command line that contains the PCW diagnostic. And the third one, command line that contains the ms-msdt -id or /id. So here are the keywords, and based on the keywords, I mean, we are going to apply these keywords in a specific logic. Look at this this condition, but before that there is another selection, and the selection is containing the command line that contains the word invoke. And here is the condition. In the condition, they are including the section 1. The section 1 should be present, and it should be selection 4 or selection 2 and selection 3. So it should be this specific selection or selection 2 and selection 3. So this is what the logic. So in order to build this kind of Sigma rule, you have to understand that zero-day vulnerability first, how the vulnerability happens, how it can be leveraged, those things and all you should understand before writing this rule. So being a purple teamer detection engineer is not easy. It would require a lot of skill, the skill of noticing, the skill of observing something. And moving to the next one, another zero-day vulnerability that made waves this past year, Log4j. The Log4j was detected at the end of 2021, but it shook many industries as it was very vast. It affected many solutions across the globe, and still we haven't completely released from this Log4j impact. And it has multiple publicly available Sigma rules, and they got one of such rules. And look at the logics here. The title, descriptions and all the same, and the tag you can see it's an initial access, persistence and privilege escalation. All right. And the log source, again, it creates process and it's a Windows machine. It impacts the Windows machine. I think the Log4j impacts all the operating system, the variety of operating systems, but this rule is for Windows. All right. And look at the detection section. Under the selection section, there is a condition, image ends with this specific name, and the next one is the image ends with these names, and the condition is this specific thing. If it ends with this name or any of these names, then it should be triggering the alert. Well, look at the false positive definition. If there is a legitimate call to the system binaries are nothing but these binaries. These binaries are generic binaries in Windows system, any Windows system, and if the call to that binary is legitimate, then it is false positive, and the company specific internal usage, then that is considered as a false positive, and the level is high. That's the severity level. Well, look at the next one. It is very interesting, and I was talking about a tool, a place to convert the Sigma rule to the signature of the specific SIM format, and here is the place, and the place is nothing but the uncoder.io, and I have already opened it here. So look at this. So this is the page where in this first place, in the first box, you can paste the Sigma rules that you have crafted, and you'll be able to transform this Sigma rule into any of the SIM format signature. Look at this signature, how many SIM solutions it supports. There are a lot: Zeek, Windows PowerShell, Sysmon Logic, Sentinel-1, Qualys, Microsoft Sentinel-1, Kibana, Greylog, FireEye, Elasticsearch, CrowdStrike, Carbon Black, ArcSight, AWS OpenSearch, Splunk Alert, QRadar, Elastic Query. Look at the list of SIM that supports. So you can simply write the Sigma rule here, and you can convert it to the convert the sigma rule into a specific SIM format, and that is very impressive. Now I'll show this. Let me grab this specific the rule, the Folina rule I'm grabbing here, and I simply copied this and I'm putting it in a sigma rule box. Now I pasted. I'm simply choosing the SIM of my wish. For example, if I am using Splunk in my infra, I'm clicking Splunk and I'm clicking the translate. Look at this. It converted this entire sigma rule into the Splunk format. So you can simply use this specific detection logic in the Splunk. You can apply this detection logic into the Splunk. So what will happen whenever the Splunk receives any logs that matches with this pattern, it will be triggering the alert, right? So it is applicable to any SIEM. For example, if I'm choosing CrowdStrike and I'm simply clicking translate, it would be converting that rule into the CrowdStrike format. So here is the CrowdStrike logic, detection logic. So you no longer to be relying on the vendor's detection logic, vendor's signature. You can make your own signature with the emerging and the zero-day threat IOCs. So that is an impressive part of this, and you have to be very careful while creating the sigma rule, because every space matters, because looks like it is space sensitive. If I'm giving an additional indentation, then it is giving invalid format. It is not doing the conversion properly. For example, I'll show one thing here. Now I have copied and pasted that rule from the TryHackMe exercise, and here I have chosen the YAML format. The syntax is set, and now I'm selecting all here. You can see the indentation, and here the indentation before the line should contain every character space. You shouldn't give the indentation by pressing the tab like this. You should give the indentation by pressing the space bar like this. Then only this specific tool supports that. So if I'm copy this specific rule and put it in the encoder, it supports. It is converting that rule successfully to another SIM format. But when you give the indentation by pressing the tab button, then it is not working in the encoder. So that is what I wanted to explain here. All right, now let's try answering the questions. The first question: upon translating the Folina sigma rule, what is the index name the rule will be using as shown in the input? All right, first of all, once we transferred the Folina sigma rule, what is the index name that the rule is using as shown in the output? Well, we have to find the index name here, and I'm using the Splunk alert for now. Let's see what is the index name it uses. Will it give any index names? And I don't see any index here, but let me read the question again. Upon translating the Folina sigma rule, what is the index name that the rule will be using as shown in the output? Well, let me translate it to the Elastic query. No, it is not giving me the index name. How can I get the index name here? Do I need to choose another SIEM index? Yeah, look at the index. When I chose the Elastic query, it gives the index, and the index name is windlog beat --, and I think that would be the answer. Let me paste it here, and that's the answer. All right, the next one: what is the alerter subclass shown in the output? And here is the hint, described by the line after alert. All right, they are asking the subclass shown in the alerter. Here is the subclass, the alert, and the subclass is debug. I think they are asking this one. Let's see. and that's the right answer. All right, change the uncoder output to elastic query. Well, here is the hint. So for the next question, we are searching it to we are changing it to elastic query. So far it was elastic alert, now it is elastic query. I am translating it. Translation is done. Which part of the elastic alert output looks exactly like elastic query? Well, let's see the hint. Part refers that either of the alert, filter, index, name, priority, re-alert, or type. All right, look at this. They are asking us to compare the output of the elastic query and the elastic alert. Look at the elastic query. So here is the outcome. It contains the process executable, process command line stuff. All right, now I'm going to elastic alert, and when I choose the elastic alert and translate, look at the specific part. The specific part is similar to the outcome of the elastic query, and that one is nothing but the filter, because there in the hint you can see the part refers either of the following. It can be alert, filter, index, name, priority, re-alert, and type. Well, we can see the filter here. So that is the part, that is the part that we need. So that would be our answer, because that resembles the elastic alert outcome, and that would be the answer, not filter. Yeah, and translate the log4j sigma rule into Splunk alert. That is the next thing. Let's grab this log4j sigma rule. All right, I've copied it and pasted it here, and I need to switch it to Splunk alert. Well, here is the Splunk alert, and I'm translating it. Now, what is the question? What is the alert severity shown in the output? Well, the alert severity is at the top. It is 3, and that would be the answer. Perfect. The next one, what is the dispatch.earliest time value shown in the output? Dispatch.earliest time value, and here is the value, minus 60 m at the rate m, and I post that outcome here, and that's the right answer. And change the encoder output to Splunk. What is the source as shown in the output? Well, I'm switching this result to Splunk, and you can see, and here they are asking the source. What is the source? And the source is Windows event log, and that's what we need. That's the right answer. And with this, we finished answering the questions that we finished answering the questions that is related to the Folina and log4j rule conversion. We converted sigma to various SIM rule formats, and we have answered certain questions. Well, moving to the next one, and this is what the theory part, the boring, this is what the practical part, the boring theory part is done. Now let's get into the practical part. Leveraging know your environment tripwires. Tripwires, actually it's quite fascinating topic. Rather than reading through this theory part, I'm just going to explain this concept with the practical stuff. So let's connect with this machine. We have already connected to this. Ensure you are connected to TryHackMe's network through the VPN, and you will be able to take this machine in RDP, and you are going to follow the specific steps mentioned here, and we are going to set up a tripwire for a specific file access. And the main thing here is we are going to set up a tripwire for any important file of your wish in any machine. It can be a server, it can be an individual's machine. There must be some confidential files and folders, right? So you can protect those files by setting the tripwires to those files. What will happen whenever any unknown person, any third party, any uh, you know adversary accesses that tripwired file or folder, then you'll be getting the alert. When the tripwire is triggered, you'll be getting the alert. When they try to read or write or delete the file, any sort of modification done to that file or any read action taken on that file, it will be triggered. The alert will be triggered. And that is the concept of tripwire. It is quite fascinating, but let me explain that. It would be even more interesting. And now we have connected to TryHackMe's machine. I took the RTP of this machine. It's a Windows machine. And look at these applications present. I'm simply hovering the cursor on this application. It says it is full event log view. So by using this application, we are going to see the events that are happening. Well, the first thing, we need to set up the tripwire. And in order to do that, I'm simply typing local here in the search bar and see what happens. We'll be getting that application local security policy, and that is what the application we need to open now. And here in this application, we are going to enable that object access identification feature, and I'll explain what it is. And in order to do that, you have to go to local policies, under the security settings, local policies, and go to audit policies. And here you can see the list of audit policies, and here we are choosing audit object access, and I'm right clicking it, going to the properties, and here you can see audit these attempts, auditing success as well as the failure attempt, and I am applying and clicking OK. Audit object access. Well, when any files on this specific endpoint accessed by the users of your mentioning, then it would be triggering the alert. That is the concept of audit object access. Well, now we have set up this security policy. The next thing we have to do is going to any folder of your wish and create a file in order to test this tripwire. In order to set up the tripwire on a specific file. Now I am creating a text document. I am giving a name, secret document. Well, that's the name here. So it's a simple text document, and I am entering some text in that. And hello everyone. Please subscribe to Perumal Jagan. All right, this is my message. I'm saving this document and closing it. Now we have saved something into this document. We added some content, and I'm keeping the cursor on this. It says the size is 51 bytes because of the content we inserted in that. And now I'm going to properties, and here going to the security part and advanced, and here in the advanced settings you can see the auditing, and here in the auditing we are going to add the audit rule, and here you can see the window opened, the auditing entry for secret document, and the principal isn't selected yet, so I'm selecting the principal here. Look at this, to select this object type, so it is asking us to select the object type and also the location, and here enter the object name to select, and here you can click the examples to see the list of object names, but I am simply entering the word everyone. So when any user access this secret document, tries to open it at least, it will be triggering the alert. Well, I'm clicking OK now, and you can see the principal is set. It is applicable to everyone, and the basic permission, I'm mentioning full control here. So whenever the file is read, the file is wrote, the file is executed, the file is modified by anyone, it will be triggering an alert. It will be triggering an event log. So that's what I'm simply clicking OK and applying it. Okay, now the tripwire is set. Well, now the tripwire is set, and I'm opening the application full event log view. So from here we can see the list of events that are happening, and whenever we trigger this secret document, at least if you try to open, we'll be seeing the respective event here. Well, in this stage you have to know, you should know the event ID in order to look for a specific event. In Windows, the event ID is very, very important. In event logs, if you see, every event has a unique ID. Every similar event has a unique ID. So you can see the event ID column here. There are a bunch of events, but you should know what event to look for. And for that, you can refer the link that is given by the TryHackMe. And I'm simply scrolling down here. We can grab the specific documentation that is given in this TryHackMe exercise. So I'm skipping these theory parts as we have already set up the TripWire, and going to this last paragraph. At this point, the setup is complete and auditing is active for our secret document. Anyone who accesses it will be logged and its details will be recorded in the security event log with event ID 4663. So here they gave the event ID 4663. So let me go to this specific part, and I'm going to filter this by clicking this small icon here, and I'm filtering the specific event, and any event with the event ID 4663, it will be showing it. I have enabled the filter here, so when I keep the cursor over here, it will be showing the logs related to that document. And look at this secret document log, and an attempt was made to access an object, and it is recorded as 4663, and that's the event ID. These are the different files, but the first entry is for our secret document. I've seen it somewhere here for our secret document. All right, I'll access this document again, the secret document. Now I have opened this document. I should see the respective event for this. I am refreshing these logs here. At this point, I should be seeing logs for the secret file. And I think to get the secret, yeah, here is the document, secret document. An attempt was made to access an object, and you can see the object name here. Well, if you write a rule to detect the events with this 4663 event ID and the specific file name to which you set the tripwire, then you can use that signature in the SIM solution, and that SIM will be triggering the alert whenever that specific file is accessed. If the file contains any confidential info, credentials, or any API keys, any secrets, then you can set this kind of tripwires to that object, so that you'll be able to secure, and you can wait for the other users to access the file. So once they touch the file, you'll be getting the alert. And that is the fascinating thing about this tripwire concept. And there is a blog that is given by TryHackMe, and that blog completely explains about this tripwire concept. And I'll share this specific blog link in the description, so you can feel free to access it and understand. Here is the blog, Object Access Events, and here they gave the list of event ID related to the object access. We have seen the event 4663, an attempt was made to access an object, but before that the handle to an object was requested. This is the first event. You would be seeing this 4656 event before 4663, because every object needs a handle before you access it. Whenever you are opening that document, then it would be requesting a handle to that object, and that is a low level thing happening in an operating system in Windows, and that is recorded as the event ID 4656. Well, All right, now let's try to answer these questions. The full event log view application comes installed with your Windows machine. Use it for the following questions. What accesses value in the log details when you try reading the secret documents contents via command prompt, via CMD? So they are asking the accesses value in the log details when you try reading our secret document. So already we have tried to read the secret document, and actually it gave an accesses value. It says read attributes, but I don't think that matches the list of the number of characters here. I think they are looking for something else. Now let's see what else we need. Look at this accesses stuff, and this is the same thing. Secret document attempt was made to access an object, and here the accesses read data list directory, and the specific accesses field contains whether the file was attempted to read or write or modify, or delete. So I think this is the specific accesses event for the file read attempt, and when I submit, that's the right answer. Well, the next one, the event ID 4663 is always preceded by this one 4656 because it needs to get the handle to that object, and I'm just filtering that event ID as well, 4656. So let me give 4656 here, separated by the comma, and clicking OK. It will be showing the events for 4656 and 4663. Look at this, the 4656 we have got, and it will be showing the events for that secret documents as well. I'm looking for that. Look at this. I think this is 4663. I'm searching for the phrase secret and match case, and look at this event. Here the event ID is 4656 and the file name is secret document, and look at the event. A handle to an object was requested. So before the 4663 event, the 4656 event is triggered. So that would be our answer, 4656. Yeah. And the next one, what event ID signifies the closure of an object? And here we have to refer the specific blog, and here they are asking the event ID that signifies the closure of an object, and the closure of an object is nothing but the handle to an object was closed. So 4658, and I think that should be the answer for this. Let's see. I'll try to close this file. Currently the notepad is opened. I'm closing this notepad, and I'm modifying the filter here, 4658 and filtering that event, and filtering the phrase secret, and the match case I'm choosing. All right, now let me look manually for that. I'm refreshing this log. Do I see the secret, match case, secret? Though it is not giving the specific secret document name, I was able to see a close handle request for notepad.exe. Look at this, Windows notepad.exe, because we were writing the content on the notepad application, and that is the text editor we were using, and the 4658 event for that specific closure, and I think that 4658 should be the right answer because it is speaking about the event ID that signifies the closure of an object, and that's the right answer. Well, the event ID 4658 helps determine how long specific object was open. What description field you will check in between the events to be able to do so? Well, let's see the hint here. Read through the external resource at the end of the task. And in order to answer these questions, we have to use the blog. And I'm searching for the 4658, and let's read and understand this question again. Event ID 4658 helps determine how long a specific object was open. What description field will you check in between events to be able to do so? I mean, to detect the duration of the specific object kept open, and that is the thing we have to find. And what is the description field denotes that, and that's what they are asking, I guess. Now let's search for the 4658 event. event handle object closed when the object is closed. And look at this line. Simply look for an instance of event ID 4658 that has the same handle ID as the preceding event ID 4658. And based on the handle ID description only, it finds the duration, how long the object was open. The event ID 4658 that has the same handle ID as the preceding event ID 4656. So handle ID looks like a promising one, and that's the right answer here. And moving to the next part, we have done the practical part now. We have configured the access object policy, and we have created one document. Going to the property, we have set the TripWire to everyone and any access, read, write, modification, anything. And we were able to see the events in the event logs whenever the file is accessed. Well, that is an impressive way to protect the specific file from accessing, from the external entities, from the insecure access. Moving to the next one, the task 5, purple teaming. Actually, it's a theory part. We've almost done with this room, but it is just a theory part. Let's read through this. To cap this room off, a quick lesson on one of the best ways to strengthen an organization's overall security posture by leveraging purple team tactics. A couple of rooms that showcase purple teaming are Tempest and Folina. TryHackMe has launched 2 rooms. They have mentioned 2 rooms here. So they are actually asking us to take these 2 rooms in order to learn the purple teaming better. And the idea is simple. If you want to see your how defenses fare against an attack, understand how a certain vulnerability works and what it looks like on the logs, and you simply want to know the extent of your visibility on your environment, simulate an attack and check the results. This is what I explained at the beginning itself. This is the role of a detection engineer and the purple teaming. You have to understand that specific vulnerability or the exploit first, how it works, what are the changes it does at the machine, and what are the logs it generates. So once you simulate that, once you recreate that event, then you will be able to see the respective logs. Then by seeing the logs, you can understand how to write the detection rule for that, because the detection works based on the logs it receives. So it is obviously going to check the logs, and it matches the specific pattern in the logs. Once the pattern matches, it will be triggering the alert. And that's the concept, and that's what they are saying in a simple line, in a single line. Well, the next one, consequently reflect on the following questions. What are the attacker techniques that you did? Which one did you detect? Which ones flew under the radar? Which one you haven't detected? So that is what the question you should ask to yourself as a detection engineer. And the ones that you detected will affirm that you are doing a good job in those areas, whereas the ones you fail to detect constitute improvements that ought to be made in your visibility and or detection mechanisms. And they gave simple description for the room Tempest and Folina MSTT, and it is better to learn this while we are doing this room. Just try to answer these questions first. Let's do this. Fill in the blanks. The Tempest and Folina rooms are the examples of leveraging the which tactic. So from this description you can understand. Let's see the Tempest first. For the Tempest room, the room creator designed full attack chain and emulated adversary from start to finish, collecting valuable logs and showcasing detection and analysis tool as the room progresses. This is a classic example of the application of purple team tactics. Well, that's what they are asking here. So it leverages the purple team tactics. All right, that's the right answer. And what is the CVE? What is the CVE of Folina MSDT vulnerability? And it's a popular vulnerability. So let's Google it. Folina MSDT CVE. And the CVE is nothing but CVE 2022-30190. CVE 2022-30190. And that's the right answer. And the next one, just an acknowledgement. Yes, I do acknowledge. And moving to the last part, room recap. So just a simple conclusion part. This room explores some of the simplest ways that the organization can leverage immediately available information, knowing your environment, and purple team tactics to develop more robust detection mechanisms, one that is more suited for each unique environment. In a world of purchase, deploy, and forget, these tactics aim to provide additional layer of security that would immediately be the value to wherever they are applied. So what they are trying to say, in the world of purchase, deploy, and forget, as I said before, organizations do buy the security solutions from the external vendors, from the third parties, and they deploy that and they will forget, because those security solutions will work based on the signatures provided by the vendor. But if you have a technique to write your own signature to detect the custom events, then it would be an additional layer of security, right? That's what they are explaining here. And this room has also emphasized the value of layering defenses. It is never a good idea to put all your eggs in one basket, in the same way that an organization shouldn't put all their time, money, reputation on the shoulders of one method of detection and or prevention. No method is perfect, so having depth in these defensive methods would allow for more opportunity to catch at the bad guys. Finally, couple of rooms that leverage purple team tactics that has been chosen method of closing this topic. Well, with this we have successfully accomplished this tactical detection, but this topic is not ends here. We'll be going to learn this topic continuously. TryHackMe has launched a couple of other rooms that talks about this signature creation and the Sigma rule conversion. So we are going to talk those concepts in an upcoming videos, and I'll be making those videos in near future. And hope you really enjoyed this. If you really did, hit the like button, consider subscribing my channel. If you have any other opinion, if you think I can improve in any of the parts, then feel free to let me know in the comment section. I'm ready to accept your valuable feedbacks, and you can also share this video among your friends in the community. Well, yeah, this video ends here. I'll catch you next time with another exciting video. Until then, I'm signing off.